afternoon, ladies and gentlemen.
Good
Good afternoon.
How many of you in the audience today know what radiation is? Up until recently, I never thought about radiation. I mean, I am aware it exists. I just chose not to think about it. How about you? How familiar are you with radiation? And in particular, with gamma radiation? Nothing? Okay. Working on this presentation, I came across an interesting quote of Norman Wisdom, who once said, "At my age, the radiation will probably do me good." Though I don't really think he was referring to gamma radiation when he said that. So today, I will introduce you into the world of radiation. A high energy package discovered in the 1900s is called gamma radiation. Gamma radiation happens mostly in space, as we can see, and is produced by supernova explosions, pulsars, and neutron stars. There are three aspects that I would like to talk to you about today: what radiation is and what are its different types, what gamma radiation is and what produces it, and how gamma radiation was discovered. So, next section will unfold each and every single one of these aspects. Therefore, I will start with explaining what radiation is and what are its different types. To do that, I will quote Michael L'Annunziata, who in his book Radioactivity, Introduction and History wrote that radiation is described as high energy packages that travel a straight path. Electromagnetic radiation is characterized by variations of electric and magnetic fields in space and time. Other types of radiation are cosmic rays, better known as gamma rays, and these come under the form of high-frequency electromagnetic radiation emitted by radioactive elements. Well, now that we know what radiation is, and I already gave you a glance about what gamma radiation is, I will proceed with detailing what produces gamma radiation. So, gamma radiation are highly energetic forms of electromagnetic radiation with a very short wavelength. Gamma rays originate in the nucleus of an atom, and they are created when cosmic rays collide with atoms and molecules of gas. In space, gamma rays are produced by hot energetic objects such as pulsars, neutron stars, and supernovas. But on Earth, gamma rays are generated by lightning, nuclear explosions, or radioactive decay. As stated previously, gamma rays have the smallest wavelength and are produced by very energetic objects. So now, let's go back to Michael L'Annunziata and quote again from his book, Radioactivity, Introduction and History, as we talk about how gamma rays were discovered. Gamma rays were discovered in the 1900s by a French physicist called Paul Villard. Villard experimented with cathode rays, X-rays, and radium rays, and his experiment led to the unexpected discovery of gamma rays. But it wasn't until 1903 that gamma rays were given their name by Ernest Rutherford. This afternoon, we have unfolded the mystery of what radiation is and what are the different types of radiation, what gamma radiation is and what produces it, and how it was discovered. So let's watch a short video that I also found relevant for our discussion today.
Gamma rays are the highest energy form of light.
There's the light we see with our eyes, but there are lots of other types of light. Gamma rays are the most energetic form of light, the most powerful.
Gamma rays are part of what we call the electromagnetic
electromagnetic spectrum, which starts in radio at very long wavelengths, goes through optical, then through X-rays, and then gamma rays are the very highest energy form of that type of radiation.
The reason that it's important to look at the high energy gamma rays is that many objects, the most violent and some of the most interesting objects in the universe, emit most of their light in this high energy gamma ray part.
And the only thing that can generate gamma rays are incredibly violent events, incredibly energetic events. And we're talking stars exploding and neutron stars with really strong magnetic fields and really exotic and strange objects like that.
It's like a Christmas tree. It's shining and it's flaring. There are eruptions every day.
Gamma ray burst being an example, something that for a brief instant of time outshines the entire rest of the universe.
These are the biggest explosions in the universe.
One memorable thought that I'd like to mention today is that gamma rays were discovered in the 1900s and scientists still study them. And why do they do that? Because they're hoping to gain knowledge of the origins of the universe, at the rate at which the universe is expanding and the size of the universe. Well, I hope you feel more enlightened about what radiation is and have a more detailed image about gamma rays. Thank you.